I was a software development engineer at a grocery delivery company, working on the service that assigned customer orders to fulfillment centers. My team had recently changed the allocation algorithm to reduce delivery distance. 2 weeks later, the percentage of orders missing their promised dispatch time rose from about 2% to nearly 7%, but only in 3 cities and mainly during the evening. The obvious conclusion was that the new algorithm was overloading nearby centers. Operations wanted us to roll it back, while the optimization team argued that capacity dashboards looked balanced. I owned the investigation. My objective was to identify a causal mechanism within 5 days, return late dispatches below 3%, and avoid discarding the distance savings unless the algorithm was actually responsible. I began with order-level data rather than city averages. I joined allocation decisions, inventory reservations, picker start times, substitutions, and courier arrival events for 6 weeks. I segmented by center, hour, basket size, temperature zone, and whether the allocation had changed after checkout. The late orders were not concentrated in the busiest centers. They clustered around baskets containing chilled items that were reallocated between 1800 and 2000. That finding contradicted both teams' explanations, so I spoke with 2 evening shift managers and shadowed the exception desk. One manager showed me that reallocated chilled orders appeared in the picking queue, disappeared, and then returned several minutes later. The dashboard counted only the final active queue entry, so it hid that wasted work. An exception agent also mentioned seeing reservation expired messages, something our service-level dashboard grouped under generic inventory failures. I traced one customer order across 5 services. The allocator reserved stock at the second center before releasing the first reservation. For ordinary goods that overlap lasted under a second. Chilled inventory used a slower warehouse confirmation path, and during peak load the first reservation remained active for up to 90 seconds. The second center then rejected the item as unavailable, which triggered another allocation. Each service was behaving according to its own contract, but together they created a loop. I tested the theory by querying reservation lifetimes for all affected orders. 84% of late chilled reallocations had overlapping reservations longer than 30 seconds, compared with 4% of on-time orders. I then replayed a production-shaped basket in staging with delayed warehouse acknowledgements and reproduced the loop. That gave me causal evidence rather than a correlation. I considered rolling back the whole algorithm, excluding chilled baskets, or changing reservation order. A rollback would restore the previous behavior but add about 1.6 kilometers to average delivery distance. Excluding chilled baskets reduced exposure but preserved the hidden sequencing defect. I chose to change the flow so the first center confirmed release before the second reservation became firm. To avoid leaving customers without stock if release succeeded but the new reservation failed, I added a 15-second provisional hold at the second center and an idempotent recovery path. The warehouse service owner was concerned that provisional holds would increase contention. I used the order distribution to estimate a peak of 32 simultaneous holds per center, then ran a load test at 3 times that number. I added metrics for overlap duration, allocation attempts, and time spent invisible to the picking queue. We released to one affected city behind a flag, compared it with a control city for 2 evenings, and then expanded. Within a week, missed dispatches in the 3 cities fell from nearly 7% to 2.4%. Reallocation loops dropped by 89%, while the algorithm retained about 92% of its delivery distance improvement. Customer contacts about changing delivery estimates fell by 18% over the next month. The new overlap metric also exposed a smaller issue in frozen goods that we corrected separately. The thing I learned was to inspect where work changes state between systems, not just the final state each dashboard reports. Every team's aggregate looked healthy because the abandoned queue entries and overlapping reservations disappeared from their normal measures. Since then, when a distributed workflow has unexplained delay, I reconstruct individual journeys first and use operational conversations to find events the telemetry may be normalizing away.